In this video, I'll be performing a modal transient response analysis on this given frame. Full details of this exercise are on page 414 of the PDF linked in the video description below. Before you start this exercise, you'll need a .zip file also included in the video description below. Inside are all the values for your areas, inertias, loads, masses, and so on. I'll first start by opening a new session of Patran. After Patran starts, I'll create a new Patran database and I'll call it problem 20. I'll hit OK on the form on the right. I'll go to the meshing tab, or before that, I'll go ahead and create a series of groups so I can put all my entities inside. So go to group, then create one group called nodes, another group called elements, another group called foundation UX, another group called foundation UI, another group called foundation RZ, another group called frame masses, another group called frame, or actually foundation mass UX. And each time I create my group, you can either hit apply or click enter on your keyboard. I'll make another group called foundation mass UI. I'll create another group called foundation mass RZ. So once I'm done with that last group, I will go ahead and turn on my So once that last group is created, I'll turn on the model tree by going to the Home tab and clicking this model tree icon. If I extend the groups, I can see all of my groups I've created. One where I'll drop all of the elements, another group where I'll drop all of my nodes. Frame masses will contain all of the masses for the frame. These three groups will have the elements for the foundation, and these three groups will contain the masses for the foundation. Right now, the foundation mass RZ group is set to current, but we need to switch and make the nodes group current. So right click on nodes and click set current. You notice it switches to nodes here. I'll go to the meshing tab and under node click edit. Here switch over to the finite elements tab. I'll need to supply the location of all of my nodes. So let me minimize this and reach into one of the files in the zip file. Here under node locations.txt, open it with Notepad++. Here I have 15 locations for 15 different nodes. I'll put all of the locations into one line. I'll copy the whole line. And back in Patran, I'll paste it in the node locations box. Once the whole string is in here, hit apply. Back in the Home tab, turn on your label control bar and click nodes to see all the numbers. Let me zoom out and let me rotate this by holding the control key, the shift key, and the middle mouse button. Once I'm done with that, you can see node 1 starts here, node 2 is here, and so on until I get to node 15 here. Next, I'll switch over to my elements group by right-clicking it and hitting set to current. Once I do that, it should say elements here. Turn off your model tree now. Back in the meshing tab, go to element, edit, and here in shape, switch it to bar. Under node 1, pick node 6 as your first node, followed by node 5. In the label control bar, turn on elements, and here's your first element. With a cursor in the node 1 box, select node 5 followed by node 7. Next, select node 6 followed by 7, 7 to 8, 7 to 9, 5 to 8, and so on. And it's important that you have the same number of elements in every spot. If you accidentally make a mistake, for example here, I've accidentally made an element here, you can hit undo here, or back in this form, you can go to delete. You can leave it as any. You can individually pick elements to delete. Here, suppose I want to delete element 8. I drop it in this box and I hit apply. If I hit reset graphics, you'll notice the element fully disappear. If I want to recreate the element, I go back to element edit. I make sure that the element ID is the same one I want. So in this case, I want element 8 here. I scroll down, drop my cursor into node 1 box, and I begin picking my node, followed by the next one. And I continue on. I'm done with this last element called 18. It's time to go and create my elements 31 and 32 here. And remember to turn off the model tree. If you have it on, you may have a little bit of difficulty picking these nodes. So if I leave the model tree on and I change the ID list here to 31 so I can create my next element. Here under node, I'll select node 2 followed by node 5, and this will create element 31. Next, with the cursor in node box 1, I'll select node 4 followed by node 6, and element 32 is created. Sometimes with the model tree on, if you start picking nodes, you'll have some difficulty. What you can do is just turn it off, and it'll get easier when picking nodes. I'll switch to my next group called Foundation UX. I'll right click it and set it to current. I'll close the model tree for now. I'll scroll up on this form and I'll type in 33 for my next element number. I'll scroll back down and under node 1, I'll select this node 3 followed by node 4. Element 33 is created. Next, I want element 1 or node 1 to node 2, and element 34 is created. Turn on the model tree again, and I'll switch to Foundation UI. Right click and set current. Make sure the element ID list is 35 next. From node 1, select node 3 to node 4. Node 1 to node 2. And you'll notice it's sort of difficult to see the numbers. Turn off or uncheck Foundation UX. And now it'll remove or hide the elements inside of that group so you can clearly see elements 35 and 36 in group Foundation UI. Next, I want to set Foundation RZ as the current group. Right click it and set current. Back in the Finite Elements tab, make sure it says element 37 here. And from node 1, start in this bottom left node called 3. Move to node 4. And your next element, ID 37, is created. With a cursor in this box, start at node 1, followed by node 2. And node 38 is created. I'll uncheck Foundation UI to hide that group. And since Foundation RZ is still checked and visible, I can see elements 37 and 38, which are in this group. Next, I want to switch over to my foundation or frame masses. So right click on this group and set it current. Back in the finite elements tab, switch shape to point. And for element ID list, change it to 21. Scroll down. Under node 1, select node 5 here. If I hide the nodes, I can see element 21's been created here. Next, create element 22 at this point, followed by this point, then element 24, 25, and so on. Make sure that you have 21 here and you end with 30 here. It's very important that you match every number of your element and node on your side. Once I'm done with my frame masses, I'll switch over to foundation mass UX. Right click it and set current. And I'll go ahead and uncheck frame masses so they are not visible. Back in the finite elements tab on the right, for your element ID list, make sure it says 39. Under node 1, select this node, and you'll see it's sort of hard to see. What you can do is turn on node size, and they'll put a marker around every node. So for node 1, select node 15. And here I've created element ID 39. Next, I want to switch to the foundation mass UI group, right click it and set current. Uncheck foundation mass UX to hide it. Back in the finite elements tab, make sure it says element 40 here. And for node 1, select node 15 again. And you can see element 40 has been created. Switch to foundation mass RZ, set it current, uncheck the previous group, foundation mass UI. Back in the finite elements tab, select this bottom node, node 15, and element 41 has been created. Now I'll select elements as my current group, and I'll hide all the other groups for now. I'll then go back to the meshing tab, and under MPC, I'll click RBE2. In the finite elements tab on the right, select define terms. First, select create independent, uncheck auto execute. Search for node 15 on the bottom. You can simply drag a box around it, or first you have to check on the nodes group. Drop your cursor in this list box, select node 15 and hit apply. It gets dropped into the independent terms box. Next, I want to select nodes 3 and 1. And I'll select all of the degrees of freedom and I'll hit apply. Hit cancel. Back in the finite elements tab, the MPC ID is 42. So type in 42 here and hit apply. Here I can see a magenta line indicating my MPC. You can turn it off and on here under the home tab by clicking MPC markers on and off. Next, I want to assign properties to my beams, the frame masses, and so on. So I'll go ahead and move to the Properties tab. And the first thing I'll go ahead and do is define a set of fields. Click Spatial. For method, switch it to fem. And here what we'll do is we'll take the areas.csv file, which is a collection of areas for each element, and we'll import this into Patran. You'll notice the first line in our column headings element and area. So in Patran, we'll have to make a modification here. Call the field areas, switch entity type to element. Under input data, click import export. For CSV import options, check ignore first line and hit OK. Select the areas.csv file and hit apply. Make sure you have 2 elements in this table. Hit OK. Hit apply at the bottom or drop your cursor in this box and hit apply or enter. Here my spatial field has been created. Next, I want to create my next spatial field. I'll delete field name for now. Under input data, select import export. And I'll import my foundation stiffnesses now. Make sure you have values for elements 33 through 38. Hit OK here and call this field foundation stiffnesses. Hit enter or apply. For my next group, I'll delete the name for now. Under input data, select import export and click inertias. Scroll down. Make sure you have 20 values in this table. Select OK, and for field name, type in inertias. Delete this name. Move on to input data, hit import export, and select masses. Make sure you have 13 values in this table, hit OK, call this field masses, and hit enter. Delete this field name for your input data, select import export, and select orientations. Here you'll get an error. Hit OK in these boxes. Under field type, select vector. For field name, we'll give it the orientations name. For input data, import that orientations.csv file. Scroll down and make sure you have 20 values. Hit OK. Hit enter or apply. Now, these fields contain all the inertias per element. They have all the masses per element and all the orientations per element. So rather than go element by element and type in every value one by one, I can do it all in one go. So under the Properties tab, we'll first define our material by clicking isotropic. Give it the name mat. Under input properties, give it a Young's modulus of 30E6 and a Poisson value of 0.3. Hit OK and click apply. Next, we'll move on to our 1D properties group and I'll click beam. Here, my property set name will be beam members. Under input properties, for material name, select the material we just made. Under bar orientations, select this icon and select the orientations field we created a moment ago. Scroll down and for the areas, select the field we made a moment ago. It's called areas. For inertia 1-1, do the same thing and select the field inertias. Hit OK. Under your application region, select beam element and pick all. It will drop all of your elements here, and if you recall and open the CSV file, there are entries for elements 1 through 18, 31, and 32. Add it to the application region, select OK, and hit apply. After this, I need to define mass properties for the frame masses. So under the Properties tab, for 0D properties, select mass. Under Property Set Name, select mass, or type under Property Set Name, give it a name of mass. For options, select lumped. For input properties, under mass, select the field called masses. For inertia 1,1, make sure this entry is blank. Select OK, and for your application region, select this point elements icon and select all of the masses as shown. First, make sure in the Groups tab you have Frame Masses turned on. And so back in the Application tab, you can scroll and select elements 21 through 30. Add it to this application region, hit OK, and hit Apply. Next, I want to make a foundation mass UX. Switch the option to grounded. Under input properties, make sure you're using the masses field. And for the degree of freedom, select UX. Hit OK. For your application region, turn on the foundation mass UX group. When you select the member, make sure point element is on and simply select this mass, element 39. Add it, OK, and apply. Next, turn off foundation mass UX and turn on foundation mass UI. Back in the element properties, give it a property set name of foundation mass UI. For input properties, use the same field masses, but your degree of freedom is UI. Hit OK. Under application region, select element 40, add it, OK, and apply. Next, I'll turn off this group, foundation mass UI, and I'll turn on group foundation mass RZ. Under element properties, give it a property set name of foundation mass RZ. Option is grounded. For input properties, the field is the same. Your degree of freedom is changed to RZ. Hit OK, and for application region, select node 40 or element 41, add it, OK, and apply. Now I'll go ahead and turn off my elements group, and if I get this prompt, simply select default group, uncheck foundation mass RZ, turn off masses or frame masses, turn off nodes, and turn off foundation UX. Make sure you can see elements 33 and 34 in the window. Back in the Properties tab, under Window Properties, select Spring. Move over to the Element Properties tab. For your property set name, call it Foundation UX. For your input properties, under Spring Constant, select Foundation Stiffnesses. For the degree of freedom, select UX for both 1 and 2. Hit OK. For your application region, select these two elements and make sure this beam element icon is selected. Add it, OK, and apply. Next, I'll turn off this group and turn off Foundation UI. In this group, I have elements 35 and 36. Under Element Properties, call this new property set name UI. Under Input Properties, make sure you've selected the Foundation Stiffnesses field. For your degree of freedom at nodes 1 and 2, select UI. Hit OK, and for your application region, you're selecting elements 35 and 36. Add it, OK, and apply. Next, turn off Foundation UI and turn on Foundation RZ. In this group, you have elements 37 and 38. In the Element Properties tab, the new property set name is Foundation RZ. For your input properties, you'll use the same field. Your degree of freedom changes to RZ. Hit OK. For your application region, select elements 37 and 38 and hit apply. So far, I've defined properties for all of my masses and all of my line elements. Next is to define our boundary conditions. So move to the Boundary Conditions tab. Under Groups, turn on Nodes. In the Boundary Conditions tab, hit Nodal Displacement Constraint. For new set name, call it 345. Under Input Data, prevent translations in the third direction, prevent translations in the fourth and fifth direction, and leave the sixth direction blank. So here I have open, blank, comma, comma, 0, then close, open, 0, comma, 0, comma, blank, close. Hit OK for application region. Switch select to FEM and hit pick all to select all of nodes 1 through 15, add it to the application region, hit OK and hit apply. I'll turn off this boundary condition display. Next, I want to define my base excitation. Under the LBC fields, select non-spatial. Under field name, call it base excitation. Check time, and for your input data, go to Import Export, find the loads.csv file, double click it, and make sure you've dropped all 28 values into this table. Hit apply at the bottom or hit enter here. And now on the left, you'll see under non-spatial, I've created my new field. Next, go to create load case. Under load case name, call it time LC. For type, switch it to time dependent. Under input data, add the boundary condition we made a moment ago. Hit apply. You can minimize this window. And on the left, under load cases, you can see the time LC case has been created. It is currently set to current since we left make current checked, so any other boundary condition I make will be added to this load case. Go to nodal force. For new set name, type in F, and for your input data, do the following. Give it a force that is 0 in the X, 8 E9 in the Y, and 0 in the Z. Scroll to the right. In the adjacent box, select the base excitation field. Scroll left, scroll down, hit OK. For your application region, you'll select node 15. Add it to the application region, hit OK, and hit apply. Turn on your elements group. Go to the Home tab and hide the model tree. I've gone to the Properties tab and defined all of my properties for all the point elements and the line elements. I've defined my boundary conditions here. Next, I'll go ahead and run this analysis. In this tab, select Analyze Entire Model. For your solution type, select Transient Response. Ensure your formulation is modal, and hit OK. Scroll down and click subcases. Here, select the time LC subcase. Make sure it's dropped into this box. And under subcase parameters, go to define time steps. For the number of time steps, type in 280. For delta t, type in 0.01 and make sure it says 280 and 0.01 here. Hit OK. Under modal damping, switch this to critical damping, and under define modal damping, make sure you have 2 rows. For frequency, type in 0. For the next frequency, type in 2000. For the values, type in 0.1 and 0.1. Hit OK and hit OK here. Under output requests, we don't want to view the SPC forces, so select it and delete it. Scroll down and select velocities and accelerations. Here what we're saying is we want to output displacements, velocities, and accelerations after the analysis. Hit apply at the bottom and hit cancel. Next, go to the subcase select. Currently, if we run this analysis, it'll run the default subcase, but we don't want that. We want to run the time LC load case and subcase. Once it's in this box, hit OK and hit apply. Given this message, I have to make a modification to my MPC. Click yes here. Click this box if it appears. Back in the meshing tab, go to action, modify, object MPC, MPC ID, select this one. Under modify terms, select nodes 1 and 3 and bubble and modify. Uncheck auto execute and only select UX, UI, and RZ. Hit apply. Make sure it says UX, UI, and RZ here. Hit cancel and apply. Back in the analysis tab, click analyze entire model and hit apply. Hit yes to delete your previous files. And the message is not here this time. To import your results, under Access Results, click XDB, scroll to the bottom, and hit Apply. Once that's done, go to the Results tab and click on Graph. Click this icon to expand all the results and select all of the results. Scroll down. The first thing we want to view are my translational accelerations in the Y direction for node 15. And hit apply. Ensure that you have something that looks like this. You can compare it to your PDF file, and that would be this graph here. Switch back to Patran. I'll clean up the view of the numbers. Now I can see my domain goes from 0 to essentially 2, from negative 135 to 135 here. If I go back to the Home tab, turn on the model tree, here in the results, I currently have this graph. I can turn it off and on. If I want to save it and review it later, I can go to Plot Options here, scroll down, and call it Graph 1, and hit Apply. I'll uncheck GRA Default Graph. You notice that my graph is now here. I can hide it. Scroll back here, go back to Select Results. The next thing I want to view are my accelerations in the Y direction for different nodes. I want to view my accelerations for nodes. Let me turn off the element numbers. Let me turn off the point markers. Let me turn on the node numbers. I want to view my accelerations for nodes 1, 3, 8, and 13. I'll hit apply. Here's my new plot. If I want to save this for later, I'll go back to plot options and I'll call it graph 2. And I'll hit apply. I can turn it off and on. And here you can see my graph 2. If I compare it to what I should get, it resembles a graph. Next, I want to view my bar forces translational for the same nodes. So back in the select results section, scroll down. And I've actually forgotten to output this result. I'll go back to analysis, go to analyze entire model, scroll down to subcases, select the time LC subcase, make sure you've dropped it in here. Under output requests, I'll select element forces. I'll select element stresses and element forces. So make sure it says stress and force here. Select apply. Confirm the modification. Hit cancel and hit apply to reanalyze this. Once that's done, import your results again. Go back to the results tab, click graph, click this icon, expand all the results. Select all the results. Scroll down and select translational bar forces. Quantity is magnitude. Go back to target entities. Make sure you've selected nodes 1, 3, 8, and 13. And hit apply. Or before that, go to the results section and turn off this plot. Now hit apply. Here I've only plotted nodes 8 and 13. Or in this case, I'm not selecting nodes 1, 3, 8, and 13. I'm selecting nodes 9, 11, and 4. So here I should select node 1 or node 9, 11, and 13. Once you do that, hit apply. Move this blue window or viewport and you can see your graph in the back. If I want to save this graph for later, I simply call it graph 3 and hit apply. Uncheck all of your plots, and here's graph 3. I can compare this to what I should get. Last thing I want to review are my bar stresses. So scroll back up, select or click on select results, scroll down and select bending bar stresses, or actually select axial bar stresses. Your quantity is the X component. Scroll up, you'll be viewing this for the same nodes 9, 11, and 4, and hit apply. Or uncheck graph 3 first and hit apply. Scroll and hit plot options and I'll call this graph 4. Hit apply. When I compare this to the last graph, you can see the resemblance. Make sure to save real quick. And now you can easily view all your results. You can minimize this window, expand this, and this concludes this example.